Great. Welcome everyone. Today is December the 3rd, EIP-7928 Breakout call number 8. Let's get started. I just posted the agenda into the chat. Today it's very lightweight, I would say. We have 3 topics to discuss, starting with one change in the specs and the EIP, more a clarification around how to treat calls that send value but run out of gas. The second one is storing the block of access list in the block body versus not storing them. We discussed it already last time, but wanted to double check with everyone. And finally, going through optimizations needed for the benchmarks we wanted to get in order to determine if the read values are worth it to include in the block of access list or not. Perfect. Then let's directly jump into the first topic, which came up as there were some differences in how client implemented the gas accounting when it comes to every call opcode. And basically it depends on when do we do the static checks versus when do we actually go to a state. And I will post this PR into our chat. 1 second. There it is. And I'm curious what clients think about it. So right now, what we do is in the specs, we now make sure that we first check all the static checks, which is memory expansion, access costs, and the transfer cost. And only if they succeed, we go to disk. And the tests showed like differences between, I think it was between BESO ref and ref versus GEF. I think GEF did something different there. And I wanted to double check with clients if this is something we can agree on, how it's now defined in the EIP. I think it only needed changes for GEF, right? Is Jared on the call? Maybe Jared, do you have some insights there? Is this something you guys are about to change?
I just joined. What are you talking about here?
Yeah, it was the topic with the call. So basically, checking all the static gas costs around memory expansion, access cost, and transfer cost before actually doing the state access.
Yeah, actually, I'm working on that right now. And I'm hoping I can get the test coverage around that fixed pretty soon. In fact, I think that there's a possibility that that might be the cause of the chain split that we see when we try to run local dev nets between Geth and Bisu. So, hopefully fixing this also makes the dev nets more stable. But yeah, I'll have an update on that soon. That's like my top priority right now.
Awesome, thanks a lot. I just relaying Stefan's message here in the chat. For memory expansion, Nethermind also has an inconsistency versus ref and Besu. Someone from Nethermind who is already aware of the topic in the call.
Yeah, sorry, what was the question, sorry?
So it's basically in the specs so far, it didn't matter that much when you do this, the state access versus when you do the static checks for memory expansion, access cost, and the transfer cost. And what came up during the testing was that, for example, if you have a call that forwards 1 ETH, but the account only has 0.1 ETH, then the question is, should the target address that is about to be called, should it be included in the block level access list or not? And I think Beso and Ref did not include it, which seemed right because you can do all the static checks before actually going to disk and actually accessing this account. So it was probably Nethermind and Geth that had this state access before doing all the static checks.
Right. Yeah. I mean, I don't have any opinion on it really. Like, I'm happy to change to what Besu and Reth are doing.
Okay, great. Maybe Felipe, as you're also on the call, is there anything you would add to this topic? Because we have been going back and forth in the specs regarding that. So is there anything you would like to bring up? Just to make sure we don't forget anything.
No, I think we covered it. I am a little curious though, because we do have this as a test and Nethermind is passing all of them. So I'm not sure, Stefan, where they have the inconsistency.
That's for memory expansion. I'm not sure if I shared the right link. When there are different kinds of gas accounting, and Nethermind reads the target. I think it's the target. I'm not 100% sure though what exactly Nethermind reads before doing the memory expansion gas accounting. The other gas accounting seem to be in line with Bezo and Reth, just the memory expansion seems to be a little bit delayed.
Yes. Okay. Yeah, you didn't share the right link. This is the PR that you added a test for and I merged. I'm pretty sure. Yes, exactly.
I think this should be the right one.
Yes.
No. So this is
Okay.
just an inconsistency I found with memory expansion. I think that's the last thing so far, and then Nethermind should be aligned. I think you just merged this recently, so it might not be yet in the tests because I think you have to make a release. I'm not sure if you've done that.
Perfect. Yeah, no, I thought we were talking about the state access. I remember this one. This is not yet in a release. We're waiting for one more PR, and then I think we're also going to be able to turn on all the old Ethereum tests with BALs, and so I'm trying to iron out some of the inconsistencies there, and then we can get a release out with even more tests that we can try to get consensus with all clients on.
Awesome, this is great to hear. So it looks like the specs are correct and the test should also be correct in this case, because then we are basically ready to test all the clients and make sure we are all aligned. Awesome. Is there anything else regarding this topic that we should discuss? It's a very interesting topic, by the way, because it's nothing that broke consensus so far, but can break consensus in the future, because suddenly, like, when do we access state will become part of consensus. Is there anything people would like to add to this topic?
Yeah, I think it makes sense to do the checks, to bring the checks that might cause it to go out of gas before the state access, because if you're going to go out of gas, don't bother accessing the state. It makes sense from a performance standpoint.
Yeah, thanks a lot for that. Yeah, I agree. Also, a lot of thumbs up here from many people. So seems like we have a very broad agreement here regarding this topic, which is great. Okay, so then I would suggest we move on to the second agenda item, which is summarized as storing the block level access list in the block body versus not storing them in the block body, plus defining a retention period. And there is this comment from Lukasz. If you scroll down at the agenda, Lukasz made a very nice summary of the pros and cons that each option brings. Maybe, Lukasz, if you want, do you want to quickly summarize your thoughts there?
Yeah, so this is basically simplicity versus UX, probably. Simplicity of implementation and of everything. So if we keep the balls in block bodies, we risk, so we will be generally increasing the gas limit, right? So we will be increasing block bodies already quite a lot. And if we store balls there, we probably risk increasing it at least 50% more than what they would already weigh. And I'm not sure if I trust this number, 50%. You can, Tony, chime in later about it. I'm like, my gut feeling is it will be even more than 50%, but that's the number you provided. So I'm not sure if I trust it, to be honest, but that's the problem. Another thing that you basically, for those blocks, keep kind of archive data in the block history. So that seems wasteful for me. And if you have an archive node, you probably still need to reindex this data in a different way. So again, this is quite useful for you. So you blow up out even more. Okay, good point that balls can be then used to quickly sync archive node later. So that's a point to just index this data. So that's the pros of kicking balls. So basically you get kind of the best of the both worlds. So pretty fast tip processing, but lower resource footprint. But if we do that, it introduces a lot of potential issues because things like, do we actually want to sync those balls at all through dev P2P? If yes, then we need to create some kind of sub protocol for it. If not, we can just ignore it. What if we don't have balls? We need to have a fallback mechanism of processing blocks if we don't have a ball, which is fine because we can verify the ball hash by generating it while processing, but it makes things more complicated, right? What else? Potentially, it reduces the speed of doing things like catching up to the head of the chain or the RPC, for example, right? So there are a lot of drawbacks that this causes. I'm not sure how balls are currently distributed on the P2P side, but if they are in the block bodies, they are probably just automatically distributed with blocks. If they weren't in the block bodies, it would have to come as a sidecar, which could have potential good and bad. Well, bad, it's again more complicated, but potentially maybe it's easier to distribute two things that are still relatively heavily, block body and ball, rather than just one thing that is heavier. So it might actually, in the end, potentially reduce latency on the P2P side. So yeah, there's a lot of things to consider, and in my opinion, it should be like a conscious decision. To be honest, I was under the impression that we won't do balls in the block bodies because that was the like when initially discussed, and I didn't like that was like idea I proposed, and then I didn't like pay that much attention. Sorry guys to this because Mark is leading the charge here on the Nevermind, championing the CAP on the Nevermind front. So I recently read it and thought, okay, that I'm not sure this is the best decision. It might be, but I think it needs to be a very conscious decision what we want to do. So just throwing this out, are we sure we want to do that? Because it's like we're increasing the history footprint probably just through increasing the gas limit, let's say by 3 to 4 times, 5 times maybe. And then if we add balls to it, we can increase it instead of 4 or 5 times to more around even 10 times. So do we really want to do it that big? That's my question.
Yeah, thanks a lot for this summary. I remember like this has been a topic in Berlin and right after Berlin. And as you already said, like one of the strongest arguments for keeping the block file access list in a block body was the simplicity. So I remember like this was by the time the argument why we ended up putting the ball into the block body. But I can totally see your arguments, and yeah, would be curious if other clients have an opinion on this already today.
So I think from an archive perspective, we're probably going to just drop the BALs from storage. And the reason for that is we can reconstitute them because effectively we've already got the access history. We record that anyway. So if we need to reproduce a BAL, it's quite likely we'll just reconstitute it from our access history. Because otherwise we'll store it twice.
Will that be on sync? Will you reconstitute it on sync?
No, so here's the question is there going to be an RPC call that's basically getting the BAL?
Yeah, give me block body, like on the dev P2P.
Yeah. Yeah, but that's dev P2P, not RPC. Is there an RPC call? Are people going to want to access the block bodies historically via the RPC?
I think there is but I think it's a debug feature to get RLP of the block, and BAL should be there, right? But that's like not a normal thing to.
Yeah. Well, I'm just saying that's from our perspective. That's what we'd be thinking about. Is there's a trade-off between storing them and reconstituting them, because we'll have the information to reconstitute them, and if because re-execution is actually quite cheap, right? Because we do it all the time for RPCs. So we've got this general trade-off that if it doubles the disk storage, we'll probably drop them, for example. Because once you're keeping them historically, that's quite a big disk budget.
Yeah, exactly. That's
I think it's not doubling it. I think it looks like it's adding like 50% on top, but not 100%. But yeah, this might not matter in the end that much.
This is analysis with the current gas limit, right? And
no, this was already with 45 million. So I remember like back then at the very beginning, we analyzed it with 30 million, and there it was 50%.
Tony, I don't really care if we are 10xing the gas limit to around 300 million. That's analysis is, in my opinion, worthless because the gas usage pattern may completely change.
Right, but the BAL size should scale sublinearly. So the BAL, because it's very well aggregated, it will never scale superlinearly.
Mm-hmm.
So if it was 50% extra at 30 million, it cannot become 100% at 300 million. It can only get you like 40% on top of it.
Yeah. So just to be clear, that's 40% over the top of the cost of the block with all of its transactions in it. Yeah.
Yes, and I will actually have to redo this analysis because I said in the chat, I posted the most recent analysis in the chat. But as you can see there, the BAL size is like 56 kilobytes compressed. That's the median. This was not yet at 60 million, so this was still at 45 million. And I just compared it with this chart that you get when you Google like Etherscan block size. And the block size there, which only considered the EL payload, is currently at around 120 plus kilobytes. So that's where the 50% are from. but I will definitely double check that and provide like clear numbers so that we know, is it like closer to 50% or 100%? But right now I would assume it's closer to 50%. But yeah, I'm not even sure if this changes something in this discussion here, because in the end it's still like significant data. So yeah, curious if we should go for the simple approach and just keep them in the block body and then drop them and be able to recompute them.
Just to add here, I talked with red team. Basically, we are supporting from dropping the ball from the block. And for us, it is simple solution for the ball to not be included in the block, not all the way around. And yeah, I'm echoing the thing about the database size and complexity on the P2P. So from red point of view, dropping ball from the block makes a lot of sense, and it's something that we would like to see.
I mean, it is a trade-off for syncing though. So, you know, because if you're a syncing node, you probably want the BALs on dev P2P.
That's
I mean,
true.
I'm just pointing out that from our perspective, we've effectively got the same data stored because we store accesses per transaction in our database. So we just physically won't store the BAL. We'll reproduce it because we've got an optimized version of it already. Which I think we're relatively neutral for that reason, is basically what I'm saying. I think, you know, at an implementation level, we probably won't physically store the BAL in our database, but we will be able to reconstitute it if somebody asks for it. And I would expect anybody who's syncing will want the BAL because it will speed syncing up.
I see a real benefit to have a block access list also during a sync, because as I said in the chat, if you don't have to replay a block, you don't have to get all of the EVM fork version. So I think it's real benefit. We will not have BAL from the Genesis, but it's still a good thing to not have to replay all of the block from the BAL fork.
Okay, guys, but what kind of syncing are we talking about? Because if we are getting new payloads, we will be getting the balls with them, right? But do we need them on the P2P?
Yeah, I think it's if you're doing dev P2P recovery, is what I'm talking about. If you're doing a backward download via dev P2P, it's quite useful to have the BALs.
Okay, but for example, we would have to store them in our especially non-archive nodes. We don't have a way of reproducing them as easily. We don't store the archive node as ref and Erigon, so we cannot guarantee them. If we want to drop them, we drop them, and we can have a retention period, but we cannot guarantee to have them.
I mean, for syncing, so what are the benefits? Say we have a retention period of like 256 blocks or something. What are the benefits of keeping them? So if you snap sync, there's no benefit to them.
But the benefit is that you don't need to heal. You can just download the range of blocks with access lists, and once
but if you've got like the last 256, you can't snap sync further back than that because you're too far away from the head.
Yeah, I guess that's why the retention period would need to be, the suggested retention period would need to be reasonably long, right?
Yeah, but only like 256 blocks or something. It doesn't need to be.
Yeah, that's not very long. Right.
Yeah, because you won't be able to get the state blocks.
Well, we should keep them up to finalization barrier, to be honest, right? Maybe.
Yeah, but that's even less. That's like 64 blocks.
Yeah, but no, the finalization barrier is like can move, right?
How can this be enforced on the P2P? We are talking about the limit of the last 10 blocks while the syncing is happening, and we don't exactly know like what kind of number are we talking about.
Okay, well, say a week or something. But I'm just beyond that period. Is there any benefit? I mean, I can see an archive node, yes, but
we don't need it.
they're quite rare.
From red side, we don't want ball to be transmitted over P2P. We're just fine having it in engine, and that's it.
So there are other things, right? So if we are definitely like our node hanged, we are restarting it, we are several thousand or 10,000 blocks behind, then when we won't get that from new payloads probably. So we need to go through dev P2P probably, right? So we are getting the blocks. Now the blocks are very big. So if we are single-threadly just replaying them, it might take quite a long time to catch up, right? So that's without balls, right? So that's a problem potentially. That the catching up process will be way slower. If we don't have a ball and we need to reprocess something, it is way slower. Another problem is that how the balls will be now distributed. If they are going as a CL sidecar, this is now a CL change, and we need to involve more CL devs into prototyping that, into speccing that, and it increases complexity on their side. So generally, it increases complexity a lot if we drop the balls. But yeah, that's kind of it.
But we can delete them from the block itself and change the RPL.
Not sure if I understood.
Well, as I understand it, we're not generating a hash multiple times. You've got the bal hash, which is the hash of the bal in the header, but then you're not rehashing the entire block to get a block hash. You know what I mean? It's the sum of all the hash. It's the hash of all the hashes. So you can just erase it from the block at some point.
Okay, yeah, you could. Okay, so maybe it comes from, okay, so we now have like a storage and networking part, but that would kind of
Couldn't ball like behave something like sidecar? I'm not exactly sure about CL details there, but shouldn't be acted like sidecar as the blobs are currently done.
Yeah, so I guess the question is, are you talking about dropping them from the EL or dropping them from the EL and the CL?
You mean because the CL has the EL block as
Yeah.
CL will still need to have them.
I would drop in both because
yeah, but is it
maybe I'm not sure. Maybe not. My comment's not good.
Yeah, because sorry, I'm just thinking this through now from a Kaplan archive node. It'll have, so we might drop them from the Aragon archive, but end up having to keep them in the CL archive, which is interesting.
How much do CLs outside of archives normally keep? I mean, do they keep all the blocks forever?
I don't know. Yeah, that's a good question.
Or do they already have something like 4/4s?
Well, I guess that's a question we should ask. So I don't know, because basically our use case is archiving, and I think we just keep everything. So I'm not sure what everybody else does.
Because I know they do the checkpoint sync, don't they?
Mm-hmm.
But I don't know beyond that what they do with their blocks.
But if CLs keep it, we are definitely more than 10xing the storage requirements. And even if we have a retention period of for like half a year or something, that still will be quite a big amount.
Yeah, so I think it's an open question. You need to check with the CL devs to. I mean, they might not have even thought about it yet.
Anyone from Bezu or Gev want to chime in? I'm not sure if anyone here. Okay.
In Bezo's side, I think we need a minimum amount of block access lists for SnapSync. As I said, I see some benefit to have block access, all of the block access lists, but if it's increasing the size.
So for SnapSync, I don't see this as a problem because I expect block access lists will be coming through new payloads, right? So you get a new payload, you start snap syncing from that new payload as your pivot for snap syncing, and you can accumulate all those balls or apply them on the fly while you snap sync. And then you finish snap sync, you go to the healing, verify you have everything or not, and be done, right? So
If we don't have
snaps,
everything, you need to find a way to retrieve what is missing.
if you don't have what?
If you don't have
Every,
everything, how you
yeah, that
can
would be normal
yeah.
healing, right? That would be normal healing.
Mm.
But you generally should have everything unless your CL didn't send you the new payloads, right? At some point. Because that's how you will get ball on the chain tip, and during the snap sync you are following the chain tip and repivoting. So I don't see this as a problem for snap sync, right? It can
How
be.
far back? How far back will the CL give you new payloads? Like if you stop your EL node and then reconnect to the CL.
So if we stop EL node, we generally restart SnapSync from scratch. At least that would never mind us. I
No,
don't think.
not
Yeah, but I
not on
mean,
Bezo.
Not on Bezu. Okay,
No.
I,
interesting.
yeah, I guess I'm wondering like if there's a lapse in the like will the CL node give you new payloads for like
Yeah, I don't know,
uh,
but generally, if it doesn't for some relatively small amount period of time, the healing at the end of SnapSync should just handle it, right? But
Yeah, but
there will be
for
problem if that's a big period of time.
for Bezo it will change significantly because for example we have a healing of the tree that is general fast, but we have the flat DB healing that can take more times, several hours. So if we have block access list, it could be really fast. If we are just missing one block access list, we'll have to do a old healing version. And it will take a lot of time. So it will be a huge difference, just for
Okay.
example, because we are missing one block access list. Yeah.
Okay, but we could have then a retention period in ELs of, let's say, a day of block access list, and that should be fine.
Yeah, if we
So
have this minimum retention and we have a way to retrieve that, yeah, it should be okay.
so I guess from Get's side, we like I voiced before that we would be in favor of some retention period that enables a reasonable probability of um of successfully syncing and using the BALs to heal without needing the heal phase. And also, I think like if we're gonna scale the gas limit to hundreds and hundreds of millions, there's like the healing phase could become a bottleneck there. So using BALs as an avenue to sort of uh, address this scaling bottleneck with the syncing is important, I think. So, I mean, we would like them, well, I say we, but it's mostly just me. I think they should be retained for some period of time and also transmitted over dev P2P.
I see also, but maybe it will be okay with GNU payload. But for example, if you stop your node and you restart your node after some times, instead of doing a backward sync and executing everything, you can also use block access list to reach the head. But maybe in this case, we'll have a GNU payload, so it will be okay.
Yeah, I think that my like what I envision the retention period being like sort of tuned for is like the to capture enough portion of the cases where maybe people like have some kind of a network event that prevents them from syncing. I think there's always going to be, if we have a retention period at all, there's always going to be a case where somebody turns off their node and powers it back on, and they're kind of out of luck because they're just too far behind the chain and they would need to restart the snap sync. But
And also, yeah, backward sync is using P2P, so yeah, it will be nice, for example, in order to sync when you restart your node, having this block access list.
Hey, one downside of this is actually I think the complexity increases quite substantially, and this might be not sure if I would say delaying because we don't have a time, but require more effort and potentially delivering the forks slower.
I mean, are you saying that implementing the replacement for the healing phase in addition to yeah, okay, so
Yeah, like just handling all the cases of block level access list available, not available, having some retention period, having dev P2P that might transmit them, might not transmit them, having CLs potentially having a sidecar for them, right? That it's complexity over complexity over complexity. Having a way of process blocks with and without them potentially might be needed. So a lot of complexity, right?
yeah,
I
for
think it's
sure. I think whatever we decide on, I mean, because we can always, if we could if we could figure out a way to avoid ballooning the complexity of the current EIP further, and then kind of push the question of, yeah, I mean, I think we should go with whatever the simplest option right now that keeps the future open for potentially replacing SnapSync.
yeah, I think it's more just to define if you want to keep block access list during a specific window, and after each client will do what they want. If they want to use this block access list to implement new feature, new optimization, but it's not really related to the fork. We can have just the block access list consensus to say, okay, we are keeping block access list during a window, specific window, and after client can add more optimization later, etc. So we are just opening the door to more optimization and features, but I don't think it will delay the fork.
Well, the second thing is how it should be, transmitted, right? Should it be with block bodies like it is now, or should it be as a sidecar? And that complicates CL side, right?
I mean, we probably should just follow up with CLs and see what their retention on blocks is, as rather than having them trying to understand the EL payload. Because if we expire them in block, say after some time, if the CL is keeping that forever, then yeah, it doesn't completely solve growth.
Dragan, you have your hand up?
Yeah, just wanted to add, if the balls are needed for the snap sync, maybe adding the additional point to the snap sync protocol is maybe way forward. It can be like, get me the ball of this block hash. Because what I'm hearing is this is mostly needed for the snap syncing, or the best use case for the ball that people want to use it is for the snap syncing or recovery from snap syncing.
Okay, and let me just quickly summarize what we just discussed. So it feels like the status quo will just stay the same for now. We will keep the block level access system, the block body, and the main argument is the simplicity it comes with, because removing it from the block body, which would mean like all the things that Lucas just iterated on, like defining retention periods, having different paths for what to do if the ball is there or not. And then we will also check with the CLs what their opinion is on the topic. But of course, we should, like, the CL side of this fork will already be quite big and quite complex. So if there is a way, of course, must be efficient. But if there is a way that we don't need to create new sidecars for the CL, it will definitely be beneficial for Amsterdam. Yeah, Ben?
Yeah, I just think one thing to check with CLs is what their retention period on blocks is. Is it forever, or do they have like a mechanism of expiring? But I do think if we keep the bells, then it's going to cause more pressure to bring up the 4/4's expiry time. So have blocks expiring much faster.
I think regardless, it will. This would be a very pressure on for force if we want to increase the gas limit a lot.
Yeah, so I guess the question is, given the current 4/4's retention period, what's the how much more disk in practice do you end up needing? Right? If you're saying it's 40% of the current blocks, it potentially is.
Yeah, might be an optimistic guess. So if you want to be pessimistic, I would do with a 50%.
Yeah, it would be good to have some kind of calculations with different block gas limits, right? What kind of things you need for, and what's the expected growth for what 100 megagas and 200, 300, right? And just showing that, because the numbers might be huge.
Yeah, because the simplest.
Yeah, go ahead, Mark.
I was going to say the simplest way of dealing with it is just to say after BALs there's a shorter retention period. I'm just thinking in terms of managing the EIP, because it does sound like there's a lot of work if we start dropping things now. Whereas by keeping things, we're just like punting the problem, basically.
I assume it would just rather than expiring things, would be just to say the bells can be optional. Just
that is
to
true.
have that door.
Yeah, and in practice, that's optional across dev P2P, right? Because that's the use case that you'd be using them, is when you're syncing them. When you're syncing, you may or may not get BALs. And then if you don't get a BAL, you're just going to have to do a full execution.
Not adding complexity in this case because we need to manage to kind of sync depending on if we have block access or not for P2P.
That is true, yeah.
Yeah, but you still need the capability to execute a block anyway. Unless you're just ignoring processing and applying BALs in the main. New form of ZK.
Yeah. Yeah, then you keep the BAL and drop the transactions. I mean, to some extent, that's a reason for not doing anything at the moment till it's kind of you let it bed in, because you could theoretically end up with a class of nodes that just want the BALs. They don't care about the transactions.
But technically, yes, you need to execute transaction just to validate the block, but in all of the other cases, you can just use block access list.
What are the cases? Well, you can probably assume beyond finalization barrier, you don't need to execute the block.
Now,
But
before for all of the block, before after the finalization, I'm saying.
Mhm.
So yeah, as I said, backward sync, all of the sync. So when you need to reach the head, reach the last finalized block. So as I said, archive node or something like that. Okay.
Yeah, so as I was saying, I think archive nodes need to just store the data anyway, but they're a special case.
yeah, archive node requirements after increasing gas limit to 300 or something would be
Yeah, that's the
crazy.
problem. Yeah. So I mean, there's a bigger problem here. Is once you got a massive, once we've got more state, I think it's part of what we're thinking about is what does an archive node look like after this, and it will get to a point where it's impossible. It's virtually impossible to have. You need an archive virtualized in order to support the data growth.
Whatever that means.
Well, it means you're not storing everything on one machine.
Okay. So distributed archive.
Yeah, distributed archive. Yeah, I think is where. I mean, I just think that's where we're going to end up, basically.
But the latency would be really bad.
It depends on your. Yeah, so that's the design space. It's like, can you end up with an archive node where you can I mean, it's a bit like it's a version of the stateless client problem, right? Because you've got network latency, not just disk latency to take into account. But yeah.
So do we agree that we keep the balls as is for now? Or yeah, Ben?
Yeah, I think the summary, since there's a couple extra use cases, like you might want to drop the transactions, keep the BAL. Then yeah, it might be better to not make the perfect the enemy of the good, and keep them in the blocks for now, and then revisit it in another EIP when we see how everything plays out.
Yeah, this is my feeling too. And just to answer the question from Dragon in the chat, like what is the as is case? It's keeping the block level access list in the block body and not having them as a sidecar.
So my gut feeling is that we need better analysis on numbers and come back with numbers and then see how many people yell at us that this is unacceptable numbers in terms of storage growth.
How would that affect P2P or database or anything?
Well, everything will bloat, right, by the size of the ball.
Yeah, that's why I'm saying.
That's the current design.
That's not that great.
Yes, exactly. That's why I brought it up.
Yeah, I know. I basically at least my mind from the Berlin interrupt that we did, we decided that ball is going to be dropped, and I had that mindset from that time. So yeah, I'm not sure if it's a good decision to have balls inside the block body.
So in my opinion, we should postpone decision by a few weeks, gather more data, gather more projections, talk with more people, talk with CL people, what do they think, talk with people that are more focused on other parts of scaling too, like is Ansgar here? Probably not. What does he think about it? Yeah, talk with Ansgar, talk with maybe some also other people that think about storage. Not sure if there are other people that are
Yeah.
outside of this meeting that are focused on storage that much. But get
In
also those
general,
projections. Mhm.
in general, the feel that I get from this call is that is this useful for the snap syncing or the syncing on the tip, but I think it's not worth it because it will blow up the database. And
Yeah, but
in
it
red
did.
case, it will.
But
In red case,
blowing out the database is just an implementation detail, right? Because I think effectively what we're saying is the RLP of the bodies that you get across dev P2P will include the BALs. Whether it bloats
No, no, it isn't the implementation detail because basically you say each node is an archive node regardless if you want it or not. Because if you need to serve BALs through dev P2P, you need to kind of have an archive node for those blocks.
yeah, it sucks.
So you like for us, if we don't do archive node, this kind of use case just becomes extent. It doesn't work.
right, because you've got to re-execute the block to get the
Yeah,
BAL
and I
back.
don't have state. I already pruned the state.
Right.
So our kind of validator optimized setup just doesn't work.
To be honest, I was a little surprised that we will store balls in the block, and that was the reason what Lucas said.
Well, it's the EIP says that balls are part of the block body. Currently, that's the current.
Yeah,
Yeah,
but
I
Right,
thought
yeah.
I just thought that the IP needed to be updated.
but
Okay.
if you've got a validator optimized node, surely you can't serve the blocks either.
Well,
Because
depends
you've
on
pruned,
the
because
okay.
if you prune the blocks, you can't deliver them.
Yeah, depends on the level optimization, but you know,
Yeah.
force dictate us how much we need to serve, right?
Yeah.
I
So
don't.
that's what I was saying. I think
Mhm.
the question is,
But the
in a 4.4's retention period,
Mhm.
how much practically more disk space does that add to a minimal node?
Well, 50% on the block bodies.
And if the CLs are
That's
storing, it's 100%.
no CLs don't CL aren't storing it in non-archive node, right? So it's fine for them on non-archive node.
Yeah.
So don't worry about that. That's only an archive node question for them if they are storing it there. Yeah, so I think everyone wants to more or less drop them, but
Yeah.
it complicates stuff potentially.
And dropping them comes necessarily with taking them out of the block body, right?
Well, either that or saying block body has optional balls, right? In certain circumstances, right? Because this block body is kind of what comes from CL. Block body is what we transmit through the P2P. So
Mm-hmm. And also like dropping them, which means we have to put them in a sidecar, right?
maybe, yeah,
Yeah.
probably.
Okay.
Not necessarily. We just erase them from the block. After a retention period, go back to the block, load it, remove the BAL, save
But
it.
then you have kind of two block bodies formats with balls or without balls. And
Yeah,
you say
so it's
that
an
block
optional
bodies
field.
can live in both states, right? Which is also might be fine, but trade-offs, right? Also, question mark if for CLs it wouldn't be more beneficial to transmit block body and balls separately for latency. I don't know.
Yeah,
But
this
it
was
might.
what I was thinking of initially. Like we keep them in the block body and you can still erase them. Because then we would not need to activate the CL to have a new sidecar.
That's doable. Just needs to be specified, right? Right now, I didn't see anything from it in the API thing. So
Right, yeah, this doesn't exist yet. So how would what would you say? How would we best specify this? So we would basically say there is a given retention period, and after that you can delete
Past the
them from the block
retention
body.
period, block bodies could be like transmitted through the P2P without it, right? Something like that. And we need to somehow potentially mark that there is a null there. So there will be probably a null pointer where balls is, right?
Mm.
Just to.
Is this something other clients are fine with too?
I will need to check, but it seems okay.
Yeah, it's a good trade-off.
I have a question. If we would switch, like if we would make a progress on the 4/4s and do some kind of like a rolling window 4/4s, would that solve all these problems? And we can keep it in a body in that case?
I would put pressure on making that rolling window very shorter.
I mean, why does it need to be specifically short? Any kind of like currently the 4/4s dictates you have to keep it since merge. So even something that is like, I don't know, a couple of months or even a year would definitely significantly help with this. And sure, you can go shorter, but I don't think you need to be super short in any kind of form.
Yeah, but I think at the moment we're keeping since the merge. Is that right?
No, I'm thinking actually going to some rolling window where we keep only the last, I don't know, since the last maybe, I don't know, 3 months or how much is subjectivity period or something like that. So going to like last couple of months of worth of bodies and receipts and balls and
So
keeping
from
it that way.
my perspective, yeah, it could be a workaround, right? You still need to keep it. You still don't really need those balls really in practice in any way because they can be regenerated from those blocks. And archive nodes still need to either double the data because they still need to keep it properly, or they will actually still remove it internally and regenerate it. So, which they will probably do. So it's like trying to ignore the problem where, like, say it's implementation detail problem, which it's fine, but yeah, I'm not sure.
Regenerating would be a problem in general because you can DDoS the P2P or drop or not respond a lot of P2P requests because it's not just like fetching something from the database, it is executing that block. If there's few blocks, that would be fine.
Well,
if
it
some RPC
depends how you store the data.
Yeah, you could probably fetch it and just compile it from the fetch data or something.
You still, for the ball, at least from, I'm not sure, but I'm not sure if Aragon stores the read list.
Yeah, that's
the
exactly
problem.
I wanted to say that the read list is the problem because the write list isn't.
Yeah.
So it's actually question mark. Do we have reads in the balls? Because if we do, then yeah, the only thing is re-executing, and if we don't, then you can probably compile it from the archive data.
Then you're basically forcing everybody to have like archive kind of node.
Yeah, exactly.
Yeah, that's not that great.
Yes,
there was a reason why it's dropped. Yeah, it opens like all of these.
Yeah, so I agree. If you start doing this stuff with bowels, which is why I sort of said at the beginning we're neutral, but other people probably aren't, because if you do start having to do this, it's a big piece of work. That's the problem, basically, because you end up having to have an incremental data store, which is not an insignificant amount of work. And it feels like dropping them given the status quo, because presumably everybody at the moment can process blocks without bowels, right? So the implementation cost is quite small.
Well, the problem is that we are currently processing small blocks without bowels.
Yeah,
right? and we'll be processing huge blocks with all balls. So for example, I'm currently implementing block STM like processing regardless of balls, and I expect we will be processing them relatively quickly. But yeah, it still complicates things, right? Complication can be huge.
It's even bigger than the archive node because we have additional reads.
Yeah, this seems like a topic that we definitely want to discuss next time on the next breakout call in 2 weeks again. I would suggest we don't change the EAP for now and gather more information, especially on the size. But also, if it feels like we will definitely have to go the path of having the balls as a sidecar, then of course the better, the earlier the better. We change something and involve the CL.
Just to
Yeah, go
surface,
ahead.
not an entirely serious thought, but it could be. Reserve one blob per block for one blob per block for BAL. We already have a mechanism to do a sidecar.
Yeah, I mean technically it would work like this, right? You would just create a new sidecar and then the BAL would come in that sidecar. Probably need a new gossip topic.
Yeah, but it could actually be a blob.
Mm-hmm.
Oh, but then you have to differentiate, etc. Probably messy.
And can it be a blob? Because if we do like a peer DAS and clients don't download entire blobs, now you break that.
Yeah, it would not be like a real blob where you do like KCG stuff with it. It would just be a blob of data that is like transmitted separately from the block body. Is there any to do for the EAP right now until we resolve that? Should I clarify anything in the EAP already, like regarding, because it feels like there is also some confusion in the chat around what does it actually mean if we keep the BAL in the block body? Can we just erase it out there after some retention period, or is that not even possible?
Yeah, because the block hash is the hash of the hash in the header, isn't it? So it's not, you don't hash all the hashes and then rehash the RLP. So you should be able to erase it. And then when you re-execute the block, you generate the BAL anyway, so that you can verify that it's correct and it hashes to the BAL hash. So, you already regenerate it, so you could delete it.
All right, yeah, I get that. Yeah, this seems like, to me at least for now, like the best solution we have, right? And if and the second best would then be the sidecar, which of course would come with a lot of complexity, because I remember like this was a discussion at the beginning, BAL in the block body versus BAL in the sidecar. And by the time CL devs were involved, and many people, also networking people, were all for keeping them in the block body for simplicity.
Just to follow up on your question, I don't think we should change the EIP at this stage.
Okay, yeah. Yeah, we're already at the very end of this call anyway. We're already over time. I will definitely put that topic on agenda for the next breakout call in 2 weeks again. Is there any last words that people want to say? Anything else we should add to that?
Yeah, so the only thing is between now and the next call, I'm going to look at how much we care about reads, because I think we should probably include do we want reads in the BAL in that overall conversation.
Yeah, this was also on the agenda for today, and to summarize it very quick, what we need to benchmark the reads is basically the batch IO implementation. So before, we don't know how much we get from reads. We wanted to test it on actual client implementations, And for that, we need two optimizations, the parallel execution and the parallel IO, because then we can create like worst case blocks and test how much faster are we actually verifying those worst case blocks, having the reads and don't having them.
Yeah, I don't want to have the call. I'm just saying what came out of this conversation for me was these two questions are actually a bit related, certainly from an Aragon implementation point of view, because that's a good point. I don't think we're recording reads, right? Which I'd forgotten about the read stuff. So I need to do some research, basically.
Okay, anything else we need to discuss? Otherwise, I would say we end the call. We're over time anyway.
Yeah, I'll quickly go over the comment that Ben had for using XOR for storing nonce. I think so. XOR essentially
Now let's
records
do
zero
that
bit.
next. Let's clarify that async, because
Okay,
this was
all right.
already a discussion point at some point. I would say we clarified that async.
All right, sure.
Because we're already 10 minutes over time. Perfect.
Sorry.
Then thanks everyone. No, it was a great discussion. Thanks everyone, and see you at the next breakout call in 2 weeks.